Today we discussed those things. ILD for longer the span, ILD for short span. That is a very simple topic. Okay, so we will discuss that problem. Okay, we will discuss that problem. See, it is a UDL of 80 kilonewton per meter. UDL of 80 have 4 meters long. Is moving from one end to the other. Sir, how it is possible? I said it's uniformly distributed load means it's a some truck which has taken by oils or cement, mortar, mixtures, anything, or a bus also. Bus also look like 80 kilometer. It has 4 meters long. Ideal. Everyone is sitting in the bus. It's like a uniformly distributed load is okay. Other on a beam of span 16 meters. Find out the maximum shear at span of 4 meters from left end. Just see, very simple. It is a span AB. You can call it as AB, simply supported beam. He asked, find out the maximum shear at 4 meters. 4 meters. 4 meters from the left end. Maximum shear, when will it happen? So it said that a uniformly distributed load of 80 kilonewton per meter of 4 meters is moving from one end to other. So you have to find out the maximum shear at that section. So just develop ILD for shear force at that section. So this section is called, just develop it. Very simple, we already know it. It will come like this. This is not exactly. This is ILD for shear, that section. Okay, so this is 4 meters, this is 12 meters. So what is this value? This value is 4 by 16, this value is 12 by 16. That's it, no? So total compulsory should be 1. Should be 1. For we developed ILD for only unit load is moving. So we can convert into the uniform distributed load to get the area. So just see, it is, when will, this is negative, this is a positive, we already know it. See, when will you get the maximum shear? When will you get the maximum shear? So it is moving from here to here. It is moving in this direction. So, okay, so just observe it once again. If the load is at here, somewhere here, so what is the intensity? Intensity is this much, na? This much. See, intensity is this much. So at that location you will get it maximum? No chance, because that intensity towards the shear at section C is very low. So when will get maximum? So the load position is thus such that the intensity towards the shear at C should be maximum. Where is the intensity is maximum? Intensity is maximum near to the C. That's it. So we will place it. How can you place it? C. To get a maximum positive shear, so compulsory the load should be placed like this. That's it, na? So that's, then only you can get maximum intensity. That's it, na? That's it. So for positive maximum shear, load placing from 4 to 8 meters. The length is 4 meters, na? So if you place like this only, you will get maximum intensity of positive. That's it. So this, see, so that's it. So see, that's it, na? So that is the idea. So find out maximum shear. maximum shear. So exactly what is this intensity? This is 12 by 16. It's total 12 by 16. It is 8 by 16 because this length is 8 na? 8 by 16. So find out maximum positive shear. What will get? Intensity 80. Average is what? Average is 12 by 16. 8 by 16 divide by 2 multiply with the length is 4. That's it. That's it. So what is that value? What is that value? Don't have calcium. Yes. So 12 plus 18. 20. So okay. 20 divided by 16. Answer divided by 2. Answer multiply with 80. Answer multiply with 2. It's 100. 100 kilonewtons. That's it. That is the maximum shear getting at that section C. Okay. So same thing you can observe it. When we'll get maximum negative shear? When we'll get maximum negative shear? Same situation. The load is attaching with negative port. This is na. That's it. When you place like this, it has a maximum intensity towards negative shear at that section of C. That's it. So see, this is maximum negative intensity. See this maximum intensity. Understood? So that's it. So suppose it has only 2 meters. It has only 2 meters. You have to place like this. Like this. When you attach at the section, then only you will get maximum intensity towards that force. Or force means shear force, bending moment, anything. That's it, na? So that's it. So if you attach like this, if you place like this, then only you will get maximum negative shear. So load placing is from 0 to 4 meters. That's it, na? So then maximum negative shear is what? 80. 0 plus 0 plus see 4 by 16 divide by 2 multiply with 4. So what is that value? 1 divided by 8. Answer multiply with 4 multiply with 80. So you will get 40. You get 40, na? So that's a 40. Okay. So minus 40 kilonewton is the negative shear. That is, you have to place it. That's it. That's it. So suppose, if the suppose see taken next problem, you can assume it's the next problem, because if you see the syllabus, so load position for maximum shear force at a section, we discuss it now. Load position for maximum bending moment at a section, we will discuss next. UD for longer than the span, UD shorter than the span. That's it, na? So now we will discuss. If suppose uniformly distributed load is exactly 60 meter is equal to the span length, so find out positive shear and negative shear maximum. That's the question. If the suppose is exactly uniformly distributed load equal to the span length, so can you find out? Same situation, no need to do. We have to find out the exact that section only. He asked only that section. So it's a 4 by 16, it's a 12 by 16. If you get the span, that's it. It's a 4 meters, it's a 12 meters. Suppose the uniformly distributed load is 16 meters. 16 meters, 80 kilonewton per meter. How it is? When you will get maximum positive shear, maximum negative shear? Same. So same values. How can you, sir? See, these are all mostly used in bridges. If you place a total 16 meters here, total 16 kilonewtons, substance 16 meters UDL like this, some portion is positive, some portion is negative, you will get something you don't know. But when will get maximum positive, maximum negative shear is, see, if the bridge is like this, if the bridge is like this, bridge is like this, the load is moving from towards from this section to, it will come like this na? When we'll get exactly the negative shear is, maximum negative shear is, load is like this, load is moving na bridges, if you see, exactly like this. Sir, how can you? So 4 meters here and 12 meters out of the span. 4 meters is out of the span because load is coming from like this. So if you see, just observe it. If the load is coming like this and just place like this, you will get maximum intensity towards negative. Suppose if the load is moving some just forward, just forward means if the load is like this, just a small forward. See, some part is negative, some part is positive. You will get maximum? No, no chance there. So suppose if the load is moving, some small part is moving here on low, okay, like this. You will get some positive, some negative. So you get it maximum? No chance. So when will you get maximum negative shear, maximum positive? Same situation, same. The load is like this only, you will get maximum negative shear. Because the span is, the load is exactly to place on the span only, you will get some positive, some negative, you will get small values. So it is almost equal to the, it is almost equal to the span length. It is equal to the span length. You have to place the load like this only. Some part is out of the span. Then only you will get. So because this is a chance is exactly there, na? The load is placing like this has a chance because it's a mostly it's a bridges. The load is coming from outside. So if you just, I already said in the previous classes, any spans are there like this only. It has like this uniformly distributed. So simply supported beams are there. Any spans, it is a one span. Another span is like this. Everything is uniformly distributed load. So we calculated for this span for particular section. The load is coming from these spans to this portion. That's it. The load is coming from before span to the next span. So at that situation, you will get maximum shear at that section. Chance is there, na? Chance is there. You don't want to put total load on that span. Okay, so that's it. So now you can find out the maximum positive shear, maximum negative shear. Okay, maximum negative. Maximum negative shear is same as it is. Previously we calculated exactly where it is, exactly like this. Same thing will come because we don't want to find out this intensity. That is going to be the another beam. Okay, so that's it. So no need to calculate it again, but write down 80, 0 plus 4 by 16 divided by 2 multiply with 4. So what is that value? That is a 40. Maximum negative shear. So suppose same thing happened. Now you can see for maximum positive shear, when we will get maximum positive shear, the load is like, see, just crossing here and load is like this. That's when you see, because you will get maximum concentration. If you put the load is like this, see, load is like this, it's a 12 meters, it's a 4 meters, 16 meters. When just passes that section, when the load is just passes that section, you will get maximum intensity. This is towards maximum intensity, you will get, see, this is total maximum intensity. Previously only 4 meters length, that's why we have to put only for 4 meters because the load is only 4 meters. Now it's a 16 meters, so you can put it. That's it, na? So see, you can put it It's a 4 meters going to be the next span. You will get maximum intensity. That's it. So that's the chances. You have two possibilities to get maximum shear at that section when that's a 16 meters long span. You already know it. You saw so many times 18, 16 wheels, 26 wheels, lorries are moving. Are understood? 26 wheels. So many cars or vehicles are transporting from one place to another place. We have to get, we have to know that uses so much, almost 16 meters long vehicles are using. Okay, so that's the possibility. Get it? That's it. That's it. Now you can find out maximum positive shear. Maximum positive shear is 80. So this intensity is what? This intensity is 12 by 16. Up to this is load is there. Okay, 16 plus 0 divided by 2 multiply with sorry, multiply with what? Multiply with what? Length of the span, length of the beam is length of the, not length of the span, UDL. What is the length of the UDL? Length of the UDL is 12. Understood? Length of the UDL is 12 because we place the load up to this only, up to this, not a 16, not a 4. Its length of the UDL is 14 meters. Previously we put up to here only, we can, then why we use 4. It's a 12 now. Are understood? So what is that value? What is that value? 12 divided by 16. It's a 360 kilonewtons is a chance. That's it. That's it. Are you getting it? So that's it. Same thing if the same for suppose third assumption, if UDL length is 20 meters greater than the span, so what will happen? Same thing will happen. 16 meters is exactly like this. You can just assume it. You will assume it. See, this is a span. You will get the, that's it. So now it's a 20 meters. So when will get maximum? When will get maximum? Maximum negative. Same thing. You have to place like this. Load is like this. Then only will get maximum. So 4 meters here. 16 meters is out of here. Out here. You will get maximum shear. Maximum negative shear. What is that value? Maximum negative shear is what? So exactly 80, 4 by 16, 0 divided by 2 multiply with 4. We have to place it. So what is this value? This value is same again minus 9, 40. When will get maximum positive shear? Same thing. You have to place load like this when the load is exactly crossing. So this is a 12 meters. This is a 8 meters. That's it. That's it. Load is like placing here totals. So what is that value? Same thing. Previously 80, 12 by 16 plus 0 divided by 2 multiply with 12. What is that value? 360. So UDL is longer than the span, or UDL is exactly equal to the span. Both are equal. Both are not equal. Both are created the influence on the beam or particular section or particular force is more or equal. Are you getting the line? UDL length is equal to the span or more than the span, create the effect on that span or on that particular quantity more or equal. Okay, so that's it. That's the one thing. So if the load is less than this span, so how can you put it? We already see it. Seen it. If the load is something 6 meters, okay, it's 4 meters, you will feel it is. If the load is 6 meters, Now we will ask 6 meters load. How can you put it? So for negative span, negative shear, you have to put it like this. 4 meters here, 2 meters out of it. Then only will get maximum intensity. Otherwise, if you put like this, some part goes to negative, some part goes to positive shear. You didn't get maximum value. So negative positive will got. Okay, you have to put like this. And positive shear, you have to put like this. You have to put like this. 6 meters. That's it, 6 meters. You can calculate it from 6 meters. You will get it. That's the idea. Okay, got it? So that's it for shear. For shear. Okay, so now we have to calculate the bending moment. So now we calculated the bending moment. Okay, can you calculate the bending moment? See it. For the same span we calculated. So for the same span we have to take it. For the same span we have to take it. So bending moment at particular section. Okay, the section is same, span same, everything is same. So see, now bending moment. Can you draw bending moment? ILD for bending moment? Easy, very easy. What is that ILD? That's it, na? That is ILD. So what is that value? This is 4 meters, this is a 12 meters. 4 multiplied with 12 by 16. That is the intensity. That is intensity. So can you calculate the bending moment? First we have to take it. It's a very, very small problem. First we have to take it for 2 point loads. For 2 point loads, so very, very small problems. If 200 kilonewtons and 80 kilonewtons spacing 2 meters apart, moving from one end to the other, what is the maximum bending moment at the section 4 meters from the left end? Okay, so he said asking that a 200 kilonewtons, 80 kilonewtons spacing apart 2 meters is moving. So look like a tractor. Engine has some load and bottom truck has certain load, na? So he's moving. So he's moving from this one position to the other position. So which one is front, which one is back? He didn't ask, he didn't give any details. Spacing apart. So you can check for this type. Otherwise you can check it is, this is 80, this is 200. You can check other this also. 2 months. For he particularly asked 200 kilonewton meter is lead the load system. If you ask like this, you have to take like this. Or if you ask 80 kilonewton is the leader or is leading the load system, you have to take it. Okay, now we can just see it. So when we'll get maximum? When we'll get maximum bending moment at particular section? So load is placing like that. How can you load place it? You have to place like it's a 200. 80 where it is? 80 here or 80 here? When we'll get maximum? So 200 we will give maximum intensity. That's it. You will get maximum value. 80. So 80 you have to put here or you have to put here, because he didn't exactly mention that which one is leading. If he said that leading is 80, so you have to put 80 compulsory here, because 80 kilonewton is leading, na? 80 kilonewton is leading. Just see this. 80 kilonewton is leading. It's the first. So we will give 200 is a exact more intensity. Otherwise you have another chance also. If you see it is 80 kilonewton here and 200 here. 200 here. 80 kilonewton is leading. So if you just think it is common thing. 80 has some intensity, this intensity. 200 has this intensity. It won't stretch maximum value. So you can easily feel that 200 is a maximum value. You can put we have to given that has maximum intensity. So that's it. That's a possible. So if 80 kilonewton is intensity is max, 80 kilonewton is leading, you have to put it like this, then only you will get maximum value. So what is that maximum value, sir? What is that maximum value? So this has 80 has intensity of 416 by 16. So this is 12 meters. So it has intensity this. And what is this intensity? What is this value? It is a 2 meters. It is a 2 meters. So can you get it? For 12 it's a 412 by 16. For 10 412 by 16 divided by 12 cancel. So same thing, 10 4, that's it. This is value is 10 4 by 16. That's it. It is 0. It has a length of 12 meters. It has a length of 10 meters. So that's it. If you place load like this, you will get maximum intensity. That's it. You will get maximum intensities under the load towards the bending moment at the section C. So that's it. You can find it directly. You can find it. So you can find it. So 200 multiply with 200 multiply with 416 by 16, 12 by 16, and 80 has 10 4 by 16. So what is that value? 4 4 4 3 600, 28 25 28 2 40 40 is 200 800 kilonewton meter. That's it. And we can also check it is if it is see if it is he asked like this, he didn't mention any load is forwarding or leading. So you can check 200 80 80 200. So sir, if you put like this, we have to put like this also, sir. How can you put 200 here, 80 here? He didn't mention which one is loading is forwarding. So can you get it maximum? 200 here, 80 here. Can you get a maximum value? Check it is the intensity. Check it is the intensity. Most probably this value is bigger. Sir, how can you say this value is bigger? This value is bigger compared to this value. How can you say it, sir? Because see, the slope is very less. The slope is very high. So the decremental is very fast. Easily you can say it, na? It is a 2 meters. It is also 2 meters. Which one is higher? Compulsory this one is higher. This value is higher. Because the slope is less, na? The incremental is very small. That is your small 8th class knowledge. 8th class knowledge. Okay. If you said just it, when a 4 meters is happening, it's a 0. If you see this 4 meters from this position, it's not a 0. It has some value. That means the slope is very less. Here slope is less. The decrements is very slow compared with the left side. So automatically you already know it. This value is compulsory higher than this value. So no need to check if you have a common sense. If you don't have a common sense, calculate this value and check it. So otherwise check it is, what is this value? So check it is, this value is, this length is 4 meters. For 4 meters, it's a 412 by 16. For 2 meters, 212 by 16. So 2 into 12 by 16. Previously you can see 10 4 by 16. What is that value? Previous value is what? So 10 4 by 16. Which one is higher? This is a 24, this is a 40. You can easily say it is there. You can easily say it is, this value is bigger. Understood? So that's it. You can check it is both sides and we will get it. Because this the slope is very small. Because the length between, the space between 280 is constant. Because the truck and the engine are, okay, that's type. Okay, that's the way you have to put the point loads for the finding out the bending moment. If someone is asking exactly particular quantity is leading, you can just put it where which one has a more load. You have to put that value on exactly on the particular section. You will get maximum intensity. You will get stretch maximum bending moment towards that section. Understood? That is idea. Okay, so now we will see this is a point loads when only 2 point loads are there. So if point loads are more, like this are a wheel of loads, 280 20 80, spacing between 2 meters 2 meters 2 meters. How can you put the load to get the maximum bending moment? We will see later today. Okay, so before that we have to put that maximum bending moment. Maximum bending moment for UDL. You will check UDL. You will check UDL. So okay, we have to check it in the UDL. We have to check it in the UDL. First preference is if UDL length is 16 meters. UDL length is 16 meters. Equal to the span length. Equal to the span length. Okay, intensity is same. Previous what we taken previously taken 80 kilonewton per meter. 80 kilonewton per meter. Okay, we have to take like this only. So see it. So again check it is. It is the simply supported beam. We have to find out the shear bending moment at particular section. Okay, this is 412 by 16. This is 4 meters. This is a 12 meters. Okay, so if UDL is 16 meters, how we will get maximum bending moment? When the load position is there, when we have to put the load like that, we will get maximum bending moment. You have to put bend load is exactly total length. You exactly cover the total length because it has also 16 meters. Na? It is also 16 meters. So you have to maintain the total load on the span. You will get maximum because it covers max intensity. Are understood? Because in bending moment there is no positive negative. So total is positive. Are understood? So that's it. You have to put that like this. You will get maximum area under the load. Maximum value contribute towards the bending moment at that section. That's it. That's it. Can you find out maximum bending moment? Maximum bending moment. So get it. So get it. So what is that value? 80. So you have to take an 80 area of this section. What is the section area? So what is that value? So 412 by 16 of so that's value of APH. That's it. That's it. That's it. What is that value? 16 cancel 2 so 6 32 multiply with 80. What is 2560? 2560. That's it. Na? 2560. That's it. Kilonewton meter. Sorry. 460. What is value? 24, not 32. 24 multiply with 80. It's 1920. So 1920. That's it, na? 1920 kilonewton meter. That is the maximum bending moment you will get maximum for that section. Okay, anything. So next, if the load is, if UDL is 20 meters. 1 minute. హలో మీల్స్ చెప్పేలే, ఎందుకంటే నేను ఇంకా కనెక్షన్ ఇవ్వలేదు. సరే. If the load is 20 meters, so when we'll get, how we'll get maximum bending? Same thing. When will load is 20 meters, you have to put the load is like this only, na? You have to put like this, otherwise you have to put load is like this only. This 4 meters goes to next span. That's it, na? That's it. If the load is 20, if the UDL length is 20 meters, at that situation also you have to put the load is covered 16 meter span only. So remaining 4 meters goes to out of the span. So maximum bending moment will come. Same 1920. So okay, same 1920. So next is, that is the important. If UDL length is 16 meters. See, already covered it 16 meters. So we will took it as 12 meters. Less than the span length. Less than the span length. So how we will do? So how can you place it? So we will see it today. So it's a 4 meters. It's a 4 into 12 by 16. Span UDL length is what? 12 meters. 12 meters. So how can you put the 12 meters? How can we put that UDL on the span? Can you put it like this? Can you put it like this? 12 meters you have to put like this. It's a 12 meters, it's a 4 meters. You will get this intensity. But see, just you can observe it. These intensities, so end intensities are light, so lesser than these intensities, na? Lesser than these intensities. So you can put like this, you will get maximum. If you put like this, you will get maximum intensity towards that under the load. Are understood? So if you put like this, something like this, that will give more chances to get maximum value. So how we will get maximum value? When exactly? So if you put like this, if you see, just observe it, these towards the intensity is very large, these intensities are very small, so you just avoid it, you can just stretch it. So how can exactly settle, how can you put it? Because it gives exactly maximum. Later it is the maximum, later it is the maximum, are understood? So we have to put the total UDL load to balance the center. Exactly, to balance the center, you can put it like this, like certain place like this, then only you will get maximum intensities under the load. You can't put right side, you can't put left side, because these intensities are small. You have to arrange. So how can you arrange, sir? So that's why it's a basic arithmetic meaning, it's a 9th class understanding. You have to put that load like it exactly balances the point. See, so how can you balance that? You have to put the load On the span, see, it is a span of, if you call it as A, B, it is a C. You have to put the load. Some part is on AC span, some part is on CB span. How can you divide, sir? Such that save, it is a divide the ratio of, it is the divide the ratio of as it is the AC and BC. Sir, don't understand. Okay, I will give it. So I will arrange. I will say exactly. So I will give it exactly. It is the span. It is the span. It is the span. It is ACB. You have to put the load. You have to put the load exactly in the ratio of AC to BC. It is a AC to BC ratio. You have to divide the load. You have to divide the load on the span AC to CB. Then only it balances exactly. It is exactly it's balanced at point C. Then you will get maximum intensity towards under the load. Understood? Exactly, it's putting like this only. You will get maximum chance. Okay. So in a exactly I will classify, I will describe another thing. So see it, I will give notation to another one, another sentences. Average load on AC is equal to the average load on CB. That's it. You have to put the load, you have to put the load exactly same average on AC and CB, then you will get maximum chances. Sir, how can you get it? Average load on CAC is equal to average load on BC. What is average load? Average load means what? This load divided by this span length. This load, see, this load divided by the span length. See, this load divided by the span length. Span length. Are understood? So average load on the span AC is equal to the average load on CB. You have to put that, maintain equilibrium. Maintain equilibrium, then you will get maximum intensities to under the point under the load. Understood? So why is that? Because see, this is this seems very small. You have not, you don't want to put like this, because the load is higher at center, later higher is near to the nut point, later higher is near to this point, right side left side, right side left side. So you have to put like this: average load on AC is equal to average load on CB. Then only you will get balanced. That's it. No? There is no need of proof. There is no proof. You have to just a common sense. Understood? Average load on AC is equal to the average load on BC. Okay. So that means if you see, just observe it. Just observe it. So this length is this intensity is W. This total length is L. L. So if you just observe it, its length is this length is Z, this length is L minus Z. Just take it as something UDL is have length of L. So average load, just is it average load W. So Z, that is the load on the span AB. Na? W some length Z. So certain Z only you have to place it. Divide by length of AC should be equal to the load L minus Z divided by CB length. That is the average load. WZ load divided by distance AC span. The load divided by CB span. That is it. So both side WW is same. So you have to take it as W. Z is AC by CB L minus Z. That's it. That's it. You have to put the like this. So now you will see. Now you will do the problem. The UDL length is 12 meters. Na? UDL length is 12 meters. UDL length is 12 meters. Just delete it. Okay. How can you place it? How can you, we have to place something. How can you place it? Same thing. This length is 4 meters. This length is 4 meters. This length is 12 meters. We have to put the uniformly distributed load average or maintain equilibrium between CA and CB. Average load on CA is equal to the average load on CB. Then only you will get maximum. So something like this. So what is something? This something is Z. This length is 12 meters now. This remaining length is 12 minus Z. So what is Z? Z is this value. You will get average load. So what is Z is? AC is what? AC is 4 meters. CB is 12 meters. This length is L minus Z. L minus Z means 12 minus Z. 12 minus Z. Okay. 12 minus Z. Okay. So what is Z? What is Z? So Z is equal to the, again we will get it. So 1 by 3. So Z equal to 12 by 3 minus Z by 3. So you will get Z plus Z by 3 is 12 by 3. Z 1 plus 1, 3, 3, 5 by 3 is equal to the 12 by 3. So 3, 3 cancel. Z is 12 by 5. 12 by 5. So what is the 12 by 5? 12 divided by 5 is 2.4. So 12 is what? 2.4. Are understood? 12 is 2.4. So you have to place like this. You have to place like this. 2.4 here. Remaining 12 minus 2.4 is what? 9.6. Remaining 9.6 put in the CB span. You will get maximum. You will get maximum intensity. Are understood? So average load on AC is equal to the average load on CB. That's it. Very simple. So otherwise you have to develop it. So again you will come Z na. Okay, you can come, it's just seed is just one thing you can observe it. Z by L minus Z is equal to the AC by CB. You can write like this. That is good. See, you can good it. See, Z by L minus Z, Z divided by L minus Z is equal to the AC by CB. Are understood? Now you can observe clarity. Clarity you can observe. The load position on the span divides the ratio. The load position between CA and CB on the span divides exactly on the same ratio of span. C divides the span. On the same ratio of the C divides the span. Z divided by L by Z is equal to the AC divided by CB. That's it. Is a good na? This is a good idea. You can understand. The load placing on the span is divides this section C. It is divide the section C in the ratio same the C position divide the span. That's it. That's it. The same ratio C divides the span AB. So like this you can find out the Z. You can place the load. Get it? So Z is 2.4. So now you can place it. We have to place it. So that's it. We placed it. We placed it. Now we can find out. Can you find out? So exactly. It's exactly 2 by 4. Or just check it is. Oh, okay. It's wrong. It says what is the ratio? Is 4 by 13. 4 12. So just check it is. Z by L minus Z is 4 by 12. It's 1 by 3. 1 by 3. 1 by 3 is what? 1 by 3 is what? 2 by 4 divided by 9 by 6 is what? 1 by 3. Yeah? No. So somewhere is wrong happening. Somewhere is happening wrong. 12 by z, 4 by 30, 1 by 13, 1 by 3. So 12 by 3 minus z by 3. So z is common. 1 plus, yes, it's a 4 by 3. 1 plus 1 by 3, it's a 4 by 3. So see, 4 by 12, it's an exactly, it's an exactly, it's an exactly 1, 4, 12, 3. 3 meters. So okay, it's an exactly 3 meters. It's a 3 meters, it's 9 meters. No need to calculate also, otherwise just see it is z divided by l minus z is in the ratio of 4 divided by 2. 4 divided by 2 means 1 by third. Just divide the 1 by third. Its total length is 12 meters na. Divide, make into 4 parts. 1 part goes to AC span, 3 parts goes to CS span. 12 divided by 4 is 3. 3 goes to AC span, 9 goes to CB span. That is just arithmetic. Are understood? Just very simple. Same in the ratio of AC and CB. So now we can calculate. Now we can calculate. This is the intensity. This is the intensity. Are understood? So what is this value? This is 0, 0. So what is 4 meters? For 4 meters, 4 into 12 by 16. For 3 meters, see, this is a 3 meters. Na? This is 3 meters means this is only 1 meter. This is 3 meters means this is only 1 meter. So for 1 meter, so 1 into 12 by 16. So same thing here is, this is it for 12 meters, 4 for 12 meters, 12 into 4 by 16. If it is 9, it is 3 meters only. So this is what? 3 into 4 by 16. No need to calculate. Just because 4 and 12 are there in the factor, you can directly write it. For 4 meters, 4 into 12 by 16. For 1 meter, 1 into 12 by 16. For here from this position, so for 12 meters, 12 into 4 by 16. For 3 meters, 3 into 4 by 16. So no need to do it because both factors are in the same factor. Same. So now we can find out this total, this intensity. That is intensity. Okay, that intensity. That's it. Okay, get it? So what is the value? What is the value? What is the value? You have to find out the bending moment is. It's not. It's a rectangular. It's like a rectangular, na? It's not rectangle, trapezoidal. So we have to take first to find out this area under the slot. Later we have to rest next area. So can you find out like this? So this area is 3 meters, na? So 80. This intensity is 112 by 16 plus 412 by 16 divided by 2 multiply with 3 meters. That is the right part. Second part is 80 412 by 16. So next it's a 3 na? It's a 3. 312 by 16 divided by 2 multiply with length is what? 9 meters. So that's it. That's it. That's it. That's it. You have to find out those total area multiply with intensity of 90. Okay, get it? That's it. What is that value? What is that value? You have to find it. Can you find it? It's 12. 12 5 multiply with 12 divided 16. Answer divided by 2. Answer multiply with 3. Answer multiply with 80. This is 450. So bottom 4 plus 3 7. 7 multiply with 12 divided by 32. Answer multiply with 9. 80. It's 1890. Answer plus 450 is 2345 4 kilonewton meter. That's it. That is the idea. Maximum bending moment occurring chances. Okay, so that's the idea of to place the load. How can you place the uniformly distributed load? between the CA and CB to get the maximum bending moment on the section C. Okay, are understood? Very simple. So there is no problem at all. It is a very simple. I said it's like complicated, but in reality it's very simple. Just place it on the span. Average load on SP is equal to average load on a CB. That's it. Average. Just maintain average. Small average. Okay. So for the rolling loads, not only two. If the loads are higher, higher. If the loads are higher, how can you place? How can you place on the span? Same thing. Average load on AC span is equal to average load on PB span. Tomorrow we will do the next problem. Okay. Next problem. If the loads are like this, rolling loads, how we will get the maximum bending moment on the section? Tomorrow we will see. Okay. That's it. That's it today.